What's up, everybody? It's Mr. Kozad again with another video lesson. This time we're going to be talking about section 7.5 from your textbook, properties of logarithms. As is the case with a lot of these videos, if this is your first time, here's how the best way to use these. If you've been around before, you know what to do. But if you're going through these, I go pretty quickly through these problems and these slides. And the intention of this is for you to pause, rewind, fast forward, go at your own pace, however fast you need to do it. Some of the things you might need to watch a couple times. Others of them you'll be ready to go after the first try. So here we go. We're going to jump right in. So 7.5, properties of logarithms. So I would take notes in a notebook while I'm going through this. And again, feel free to pause, rewind, fast forward, whatever you need to do. Okay, here are some of the basic properties of logs. So whenever you see log base b of b, when the base and the number you're taking the log of match up, okay, that's essentially asking you b to what power equals b. Well, hopefully everybody knows that it would be to the first power. So anytime you have a log where the base and this number that you're taking the log of are the same, that automatically equals 1, always and forever. Okay. Now the next problem, log base b of 1 equals what? So this is asking us to take b to a certain power, and what power makes that equal to 1? Well, there's only one exponent that makes any number turn into 1, and that is the 0th power. So anytime you take the log base b of anything, this base can be any number, okay, of the first power equals 0. I'm sorry, not of the first power. When you take log base b of 1 is the right way to say that. It's always going to equal 0. Okay, basic properties, 2 of them right there. Log base b of b equals 1. Log base b of 1 equals 0. The next thing that you have to know is, we've kind of already talked about this in the last lesson, but log base b, it doesn't matter what this base is here. It can be any number, okay, as long as it's greater than 1. I'm sorry, greater than 0. Whenever you take log base b of 0, okay, that is actually undefined. You can't do it. It's undefined. And the same can be said, log base b of any negative number is also undefined. You can't do it. So remember, we're only allowed to take the logs of positive numbers greater than 0. Okay? Now there's a few other properties that you're going to need to know. The first is called the product property. And what the product property tells us is, if you have something like log base b of m times n, that's what's happening there, multiplication, m times n, okay? Here's what you can do when you're taking the log of two things that are being multiplied. You can actually split this into two logs. So log base b of m plus log base b of n is how you can split up two things that are being multiplied together. Two things that are being multiplied together, you can split it up by using addition. Okay. So next, simplify the expression. How are we going to use this? So the way that we could use this is, we could rewrite this, since the bases are the same and I'm using addition in between these two logs. I can rewrite this as log base 5 of 625 times 25. 625 times 25. Now, to make this a little bit easier for us to evaluate, okay, we would do 625 times 25, whatever that is. I don't have a calculator on me or my phone on me to be able to do that quickly, but you could just do that, 625 times 25. Now, you could actually simplify that even a little bit further, but we'll talk about that here in a little bit. Okay, so if we look at number 2, example 2, expand the expression. What we can do to expand this expression is we look to see that we're taking the log of a number, and there's actually 3 things that are being multiplied there, 6 times x times y. So I can actually split that up into 3 different logs. The base stays the same in all of them. So log base 2.3 of 6 plus log base 2.3 of x plus log base 2.3 of y. I split that into 3 separate logs, and they're all being added because I'm taking 3 things that are being multiplied here. Okay, this is called expansion. Keyword, expansion. The next property we're going to talk about is very similar but a little different. It's called the quotient property. Now the quotient property teaches us how to handle something that we're taking the log of that's not being multiplied, but that's actually being divided. Quotient property. And what this does looks very similar. We're going to split this problem into two logs, but instead of adding, we subtract. So we have log base b of m minus log base b of n. We split that log up in two different logs where we use subtraction. So for example, 3, if we wanted to combine those two logs together into one, okay, if we wanted to combine those two logs together into one, we could do log base 7 of 49 divided by 7. And then if I wanted to actually divide that out, I could say log base 7 of 7. 49 divided by 7 is 7. And there's one of those basic properties we saw at the very beginning, is when we take the base and this number are the same, we can replace that with 1. So this just equals 1. If you look at example 4, there's that word expand again. Okay, expand the expression. That means we're going to take this log and stretch it out to as many different logs as we can. So here I can already see that I'm going to use the quotient property. So we've got log base 8 of 6x minus log base 8 of y. Now you could stop here, but that's not actually expanded completely yet, because look at the first part, log base 8 of 6x. 6x is a product, so we can split that up into two logs. So we have log base 8 of 6 plus log base 8 of x. That's just like what we did on the last example, or the last property, the product property. We split products up into two logs using addition. And then we still have this minus log base 8 of y. So we actually split that problem into three different logs. Log base 8 of 6 plus log base 8 of x minus log base 8 of y. Okay, the next property that we're going to talk about is called the power property. And the power property teaches you what to do when you take the log of something that's being raised to a power. This one's actually really simple. What you can do here is you take that power, whatever it is, and you slide it out in the front of the log like multiplication. So that would become p times log base b of a. You slide the exponent out in the front as multiplication, and then leave the a. The a stays. The a doesn't come with it. Okay? So look at example 5. It says simplify the expression log base 10. Remember, when we don't see a base, it's base 10. So log base 10 of 25 to the 4th power. Now you might be thinking, there's no way I want to do 25 to the 4th power, and I'm just like you. I don't want to do that either. So what I'm going to do is I'm going to slide that power out to the front, and I've got 4 times log of 25. Now you could stop here, but it's not simplified as completely as it could be. Because what do you recognize about 25? How could we rewrite that? If you said that we could rewrite that as 4 log 5 squared, you are right. And I really hope you even said it out loud. Don't worry, it's not weird to talk to the video. I'm talking to a blank screen right now. It's not weird at all. So then we can actually apply the power property again. We take this exponent, we slide it out in the front, and what do you think we do with the 4 that's already there? Hopefully you said multiply, and that's what we're going to do. We're going to take this 2 and we're going to slide it out in the front and multiply it by the 4 that's already there. So that becomes 8 log base 10 of 5. Final answer. Example 6, there's that word again, expand. We're going to expand the expression out into as many different logs as we can get. Okay? So log base 3 of 6 over 2x all to the 2nd power. Okay? So there's a few things that I see here that are going to happen. So the first thing that I'm going to do is I'm going to take this 2 and I'm going to slide that out into the front. So we have 2 times log base 3 of 6 over 2x. Then what I'm going to do is I'm going to apply the quotient property here because I have 6 divided by 2x. But don't forget that everything is being raised to the second power here. If you look back at the original, everything's being squared. So every log that we write needs a times 2 in front of it. So this becomes 2 times the log of 6, base 3 of 6, minus, because it's quotient property, 2 times log base 3 of 2x. Then from there, I can split this up, this 2x, into 2 more logs using the product property. Now be careful here, because when you split this up, you have to distribute the negative sign. So it's actually going to look like this. 2 log base 3 of 6 minus 2 log base 3 of 2 minus 2 log base 3 of x. Notice how both of these logs have a subtraction in front of it. Okay, kind of a cheat code to this, if you will, is anything that's in the denominator of a fraction, when you split it up, should have a minus in front of that log. On expansion problems, I'll say that again, on expansion problems, anything that's in the denominator of a fraction should have a subtraction sign in front of it when you expand. Okay, so there would be one way to format your answer. Now, if you're thinking to yourself, Cozad, couldn't we have just factored out a 2 here and did 2 times in big parentheses all of these? You absolutely could. This is just one of many ways that you could represent an answer to this problem. Okay, the next property that we're going to look at is the change of base property. And the change of base property is really, really interesting and important to know, because back in my day, when our graphing calculators that we were able to use did not have the a function that allowed you to change the base to any sort of number. Your calculator today can do that for you. It's awesome. But it used to be that you could not do that. So you had to learn this change of base formula so that you could use your calculator to actually evaluate what some logs are. And here's how it works. You can pick any base that you want. Okay, any base you want. Let's call it a. So log base a of x over, split it into 2 logs, log base a of b is how you could do that. Now, the most common log base that we use would be base 10, because like I said earlier, if you use base 10, you can plug those logs straight into a calculator to evaluate it for you. So if I used base 10, okay, here's what it could look like. Log of x divided by log of b. Most common mistake here is this is not equal to, most common mistake, this is not the same as log of x over b. A lot of times people want to combine those into one log, and it is not the same. You can't do it. Don't do it. Do not do that. It's very, very bad. Don't do it. Okay? So look at example 7. It says simplify the expression log base 6 of 240. Well, if I wanted to use the change of base formula to be able to type this in, I would do log 240 divided by log 6. So then I could type both of those into my calculator and see what I get. So let me grab a calculator here. And literally on my calculator, I'm typing log 240 and dividing it by log 6. And I get approximately 3.06 as my answer. 3.06. Okay. Example 8, you could do the same way. You could use change of base formula. You could do log base 10 of 81 divided by log base 10 of 0.25. And then again, I'm going to type that in my calculator. Then I have log of 81 divided by log of 0.25, and I get approximately negative 3.17 for that one. Okay? So that's actually all the properties that you need to know there. So the next couple things we're going to do is we're going to actually practice with some of these properties. So here are 4 different expressions, and your job here is to match 1 through 4 with the same value a through d to see which are equivalent logs. So pause the video now, take a look at these, see if you can get the right, match these up to the right places, and then we'll talk more about this in just a minute. Okay, hopefully you're back. I love matching because once you kind of get started with matching, it gets easier the farther you go. So I'll kind of go through this quickly again. You should have first saw that this is addition, so you can take the square root 2 and square root 8 and multiply it, and you get square root 16, which we know simplifies to log of 4. So we should have matched 1 with answer choice C. Number 2, we use the quotient property. We see the subtraction sign, so we can rewrite this as log of 4 divided by 10, which reduces to log of 2/5, which is answer choice A. Number 3, we have two properties here. We're going to do the power property, so we're going to rewrite this first log as log of 4 squared, which is 16, minus log of 2. So the second step is I'm going to combine those by dividing. Since it's a subtraction sign here, I'm going to do 16 divided by 2, and I get log 8. And obviously the last answer choice we have left is answer choice B, but let's just make sure. So I can take this negative 3 and slide it back as an exponent, so that becomes log of 1/3 to the negative 3 power. 1/3 to the negative 3 power turns into log 27, which is, in fact, answer choice B. So the order should have been C, A, D, B. Pat yourself on the back if you got 4 out of 4 correct. Okay, the next thing that you're going to do is there's a set of questions that you are going to practice these. So you have two different directions you're going. At the top, we're going to expand. At the bottom, we're going to condense. Okay, the top we're going to expand. The bottom we're going to condense. Now I've crossed a few of these problems out here so that you don't have to work on those. I'm hoping that the screen resolution on your video is good enough that you can read what these are. If not, I'm really sorry. In just a minute I'll try to make it a little bit bigger for you. But you've got two different sections here. You're going to expand the numbers on the top into as many different logs as you can get. And then on the section on the bottom, you're going to go the opposite way. You're going to condense these logs down into one log. Okay? So pause the video here, work on these, take as long as you need, and then when you're ready, start the video again and I'll show you some of the answer choices. Before I do that, let me try to make this a little bit bigger for those of you that might have a hard time seeing it. So now all of the ones that I scratched off, so let me scratch them off again. Oh, sorry if that made you dizzy. That was pretty crazy. So I'm crossing off the ones that you do not have to do. I'm crossing off the ones with LN. That's a special type of log that we will look at in a couple lessons from now. Okay, so that might be a little bit better. So take a look at these and see what you can do. All right, welcome back. Hopefully you actually worked on some of these. Hopefully you did all of them, but you probably only did a few, or maybe you have a few questions. It is what it is. I'm going to show you some of the answers here, okay? So you can kind of see and check with what I've got. So here are the answers to the first few questions, the expansion section, okay? So take a second and kind of check your work on these. You can pause it here and check your work and see what you get. I'm going to talk specifically about a couple of them here in just a second. So if you look at 14, you may have actually on 14, you may have stopped right here on 14. And you may have forgotten that this log base 2 of 2, we can simplify that to 1. So 1 times the 2 that's already there is where I got the minus 2 from. You know, in that same regard, if you look at 18, on 18, I had log base 9 of 3. A lot of you may have stopped there as your answer. But this is one that you could evaluate. 9 to what power equals 3? Well, 9 to the 1/2 power equals 3. So that's why I got minus 1/2 here as well. Okay, so double check those, see how you did. If you need to go back and rework some of those, feel free to do it. Finally, I'll show you the answers to the last 4 questions where you condensed it down to one log. Okay, I think that these were a little bit more These are a little bit easier, self-explanatory than the first set was. But double check your work, see what you get. I would definitely make sure that you have the square root of x on number 22, okay, and go from there. All right, well, hopefully this was helpful for you. If you have any questions, please reach out and let me know, and I'll see you next class.